Section 3.4 Derivatives as rate of change. Question number 1. We are given the position function s of t as shown in the picture. We need to find the graph of v prime of t. So it's very important that you notice is v prime of t, and in another word we are looking for the acceleration function. So a of t. So keep that in mind. But in order to find that v prime of t, we first need to find v of t. So we create a graph t with respect to velocity. And velocity v is the derivative of the position function. So the derivative also referred as the slope of the position function. Then we observe the graph of the s function to figure out what we have for v. And we notice that from 2 to 3 is constant, is not changing. Anytime when the function is constant, its slope is 0. So from 2 to 3 is 0, 5 to 7 is 0, and 9 to 10 is 0. And we also notice that it's increasing from 0 to 2, it's increasing everywhere. Okay, so what it just tells us, when s is increasing, we notice the slope v must be positive. The slope has to be positive for the function to be increasing. So what it means is v is positive, okay? It's positive going up, and then somehow it has to come down to get to 0. And then it's positive again, go back to 0, positive, go back to 0, positive, and so on. But this is just the graph for v. The question is interested in the graph of v prime. And what is v prime? It's just acceleration. But we just need to use our knowledge for derivative. In this case, we still do the observation where it's constant is from 2 to 3, 5 to 7, 9 to 10. And it's increasing and then decreasing. So what it means is it has to be positive, okay, somewhere here, and then it's negative, because when v is decreasing, v prime somehow is negative. When v is increasing, the slope v prime is positive. So in that case, we can see from increasing to decreasing, it has to go from positive to negative. Okay, positive to negative, positive to negative. So this is the graph of v prime, and you just need to match the graph. Now, once you have the graph for v and v prime, you can answer the choices that is on the statement, whether it's true or false. So for the first one, there are times where v prime of t is 0 and v of t is not 0. When we evaluate, so this statement A, there are times that v prime of t is 0 and v of t is non-zero. So we need to evaluate whether it's true, and we just need to look at the graph. Okay, is there any time v prime of t is 0? Yes. Is there any time v prime of t is v of t is non-zero? We go back to this v graph. Yes, that's so choice A is correct. It's a true statement. Now for choice B, it says when v of t is positive, so v is positive, v prime must also be positive. Is that true? Okay, take a look at the first hump. V is positive in this region. Okay, all positive because it's above the t-axis. But in this same region, v prime is positive and negative. So this statement is false by just looking at the graph. Now take a look at C. When V prime is negative, the car is slowing down. So what does it mean by slowing down? It means V is decreasing. So is that true? Well, take a look, observation, right? When V prime is negative, right here in this region, V is slowing down, means it's decreasing, okay? So in general, when the derivative is negative, the function is decreasing, and you can verify by just looking at the graph. So the statement C is correct. Statement D, the function V prime represents the position of the car, which is obviously wrong because V prime is the acceleration. What is the position of the car? S represents the position of the car. So choice E, if V prime is 0, then V of t must be 0. V prime of t equals 0 imply V of t equals 0. I think you can just look at the graph to verify that that's not true. Because right here, this point, when V prime has to change from positive to negative, it has to cross the t-axis. So here V prime of t equals 0, but V of t is up here, is positive. So it's not true. And then the G statement, the function V prime represent the acceleration of the car, so V prime represent acceleration. That's true. Now H is obvious because it says none of the above are true. All we need to do is take a look at A to G. Do we have any true statement? If there's any, then H is not true. So the correct choices would just be A, C, and G.